Today we will see round robin scheduling algorithm. So let us look at some of the key points. So the first point is that it is preemptive scheduling algorithm. We have already discussed the concept of preemptive, that is the processes are non-cooperating. That is, while a process is in execution, other process may interrupt that process which is in execution in the CPU, and thus it will be taken out of the CPU and the process which is interrupted will moved in the CPU. The CPU is shifted to next process after fixed interval of time called time quantum. So generally we can think of three processes, P1, P2 and P3. So each of the process will be given a quantum of time. Let us consider the quantum to be 2. So each process will run for 2 clocks. Then it will be replaced by another process which will again run for 2 clocks. And then that process will be replaced by another process after that 2 clock interval is over. So if we are considering P1, P2, P3, so P1 will run for 2 clocks, then P2 will run for 2 clocks and P3 run for 2 clocks, and then the process is repeated again, and this 2 clocks is nothing but the time quantum. The process that is preempted is added to the end of the circular queue. So when P1 is interrupted, it is moved to the end of the circular queue. So let us look at one example to understand this. So in this example, if you see, there are three processes P1, P2 and P3, and they have their burst time 4, 3 and 5. And the time quantum considered here is 2. So P1 will execute for 2 clock cycle, that is this quantum 2. So P1 will execute for 2 clock cycle. So it has now 2 more clock cycles to complete its execution. It initially needed 4. 2 it has been allotted to the CPU and 2 more it needs to complete. Next process is P2. So P2 is allotted again 2 clock cycles and it needs 1 more clock cycle to complete its execution. Similarly, we have P3 which is again given 2 clock cycles from 4 to 6 and it needs 3 more clock cycle to complete its execution. Now this particular process order P1, P2, P3 will be repeated again. So P1 will again be given 2 clock cycles. Now it has completed its execution. So initially P1 needed 4 clock cycle. So this is the first clock cycle given to P1 and this is the second clock cycle that is given to P1. So 2 plus 2, 4. So P1 has completed its execution. So that is why we put at 0, that no more cycles or clock cycles are required by P1. Next is P2. P2 needed 1 clock cycle, so from 8 till 9 it is given 1 clock cycle. Remember that if the requirement is less than the quantum, in this case quantum is 2 but the requirement is 1, so it will be given this 1 quantum, so 8 till 9. Next, process 3, as process 2 has also completed, marked by 0, so process 3 will be given 2 quantums, 9 to 10 and 10 to 11. So it needs 1 more. Now as P1 and P2 has completed its execution, so 1 more clock cycle is given to P3 in a continuous way. So till 0 till 12, this is the order. Now let us see 2 more things to remember. First, with very short time slice, that is the quantum is very short in this example 2. So considerable amount of time will be wasted in context switching. So we have already discussed context switching. So when the CPU switches from one process to another, then the PCB is saved and PCB is loaded. PCB of P1 will be saved and PCB of P2 will be loaded. So the context switching concept here will be more. So a lot of time will be wasted in this context switching. When the longer time slice is considered, for example quantum of 5, 10 and so on, so the round robin scheduling algorithm will be converted to FIFO. Now let us calculate the waiting time. So if we look at the example, we see that P1 the burst time is 4, but if you have to calculate the waiting time, we see that P1 executed from 0 to 2 and 6 till 8, and this is the waiting time. 2 to 6 is the waiting time for P1. So the waiting time for P1 is 4. 2 to 6 is 4, and the turnaround time of P1 is waiting time plus burst time. So 4 plus 4, burst time is 4, waiting time we have just now calculated, which is 4, is 8. Similarly, the waiting time for P2 is waiting for this amount of time, that is 2 clock cycle. Then the next chance P2 is getting after 4 clock cycles. So 2 plus 4 is 6. So this is the waiting time of P2, and the turnaround time is waiting time 6 plus burst time 3. Burst time of P2 is 3, so 6 plus 3 is 9. And finally, if we see the waiting time of P3 is waiting for P1 and P2 to complete, so this is 4 clock cycle, and P3 is again waiting for P1 and P2 to complete. So in this case the burst time is 3, so 4 plus 3 is 7. So waiting time for P3 is 7, and the turnaround time is 7, that is the waiting time, plus 5, that is the burst time. So this is 12. So that's all for round robin scheduling algorithm.